Okay, so guys, today we're going to talk about essential question 1 from Big Idea 1. We talked about Big Idea 1, it's a scientific method. So we're going to talk specifically about certain pieces of the scientific method. Essential question 1 is how do I make observations and calculate data involving metric units? Now metric is what is kind of the key in all that, because we don't use the metric system on a day-to-day basis. Okay, we use the US system because we have our own system. So the metric system, and this is what you're going to want to take your notes on, so you're going to want to write this down. The metric system is also called the SI system of measurement. Now why is it called SI? In French, which I do not know any French, so I would read this incorrectly, but up here in the bold, does anyone take French? French? Anybody? Anybody?
I will be next semester.
I don't know what it says either. Okay, so Système International, something, of units. So SI, it's in that, we call it SI because it's in that order in French, okay? So it's the SI system of measurement. You'll hear it called like SI units a lot, especially as you get into the other science classes. It is the most widely used system of measurement. So we're talking basically everybody else in the world except us, okay, uses the SI system. It is definitely the most widely accepted system in science, so you're going to see metric system from now till forever, okay, in terms of your science classes. And it's built on 7 base units, so we'll talk about the base units here in a minute. We are going to practice measuring with and converting these units. So typically with measurement, especially like length, you're used to using inches or feet, things like that. We're going to start working a lot with millimeters, centimeters, meters even, okay? And being able to understand the difference between them and compare them to our own system of measurement. So if I say something about a meter, you can visualize what that distance is, okay? All right, so before we get to that, okay, so what I want you to copy down is this chart. I'm going to try to zoom in on it a little bit. Zoom. Okay, so the top of it says when you are, so you need to copy down this table, okay, is the moral of the story here. We're going to talk about what the standard SI units are for each of these measurements. Okay, so go ahead and copy this down first. When you are measuring, and then mass, length, volume, force, temperature, and time. We're going to use this standard unit, and we'll list the name of it there, and then we're going to list the symbol for the unit also. So go ahead and copy down the chart. again, each of these is going to be the standard unit that we'll use, and it's also going to be the base unit of each type of measurement. So when we talk about, measuring in mass, we don't just measure in the standard unit, but this is going to be the one that they base everything else off of. So for mass, the standard unit is a kilogram. Whoa. Hold that thought.
It zoomed in a lot.
Oh, it's zoomed in. Duh. It's okay. You're right. Zoom out. There we go. Alright, let me fix this real quick. Okay, you can go ahead and write kilogram. That's the standard measure for mass. And in Paris, there is actually a piece of metal that is like the standard for a kilogram. So it's what we base our kilogram on. And the reason we use kilograms instead of grams is because grams are so small. There's a lot more room for error. Okay, when we're talking about measuring really large things. So they use kilogram as the standard unit of measure, and the symbol for kilogram is kg, both lowercase. Okay. All right. Standard unit for length is the meter, and the symbol for meter is just m, lowercase also. Okay, and please use lowercase and uppercase letters as I show those to you because there is a difference, so you want to make sure you use those. Okay, standard unit for volume is a liter, lowercase l for the symbol. Standard unit for force is a newton, and the symbol for that is a capital N. We'll use newtons a lot when we get into our physics units towards the end of the semester. So we'll talk about force towards the end, like units 5 and 6. Temperature is degree in Celsius. So where we typically use Fahrenheit. SI. Okay, so degrees Celsius. And then time is the second. And lowercase s.
So everybody just used the same.
Yeah. Time is across the board. It's the others that are typically different. What's our standard unit for length? Feet, right? And then we use inches. What's our standard? Well, so mass and weight, then you get, we use pounds for weight, where the rest of the world basically uses kilograms. What do we use for temperature? Fahrenheit versus degrees Celsius. Okay. Force is pretty typical too, but okay, so going back to this. Okay, so what we need to do now is talk about how to convert the metric system into different measurements. So those units that I gave you are the standard units for each type of measurement, but we're going to talk about how to move them between the different measurements. So King Henry died by drinking chocolate milk. If you remember that sentence, then you are remembering the prefixes for the metric system in order from kilo to milli. Now there are more in both directions. They go higher than a kilogram or a kilometer or a kiloliter. They go higher than kilo. They go smaller than millimeter, milliliter, or milligram. They go smaller than that too. But these are the 7 that you are responsible for being able to convert between. Okay? So you are going to want to write this down. King Henry died by drinking chocolate milk. At least write down the sentence. I'm going to give you a paper that has this chart on it, but it's written vertically instead of horizontally. we'll talk about why I like to write it horizontal versus vertical. This paper will also go in the Unit 1 section of your binder. Okay, so if you'll take a look at this chart, again, you'll see that it's written vertically. Does everyone see where kilo is? Look at the side with the chart on it. Does everyone see where kilo is and then down to milli? Okay, it's written vertically versus horizontally, but the same information is what's up on the board. So what we're going to talk about doing is how do we take a measurement and convert it to something else? So let's say, for example, that I measure something and it's 500 millimeters. Okay? But let's say I need the measurement in meters. I need to know how many meters that is. Okay? So I'm going to change 500 millimeters to meters, and this is why I like to write it horizontally. Because we're going to move the decimal point either to the left or to the right, because everything in the metric system is base 10, okay, which works out really well. Okay, like, you know, where ours, we have 12 inches in a foot, okay, everything in the metric system is based on 10. So we're able to just move the decimal point either to the right or to the left based on how we're converting the measurement. So right now we're going from millimeters to meters. Now, right here in the middle, okay, this is really important. Right here in the middle, the base unit. Base unit is either grams, meters, or liters. Those are your three base units. Okay? And those are three we're going to use. I shouldn't say it like that. Those are three we're going to use. You could have seconds in there. You could have some of the other ones. But we're going to use grams, meters, and liters. So when we're talking about taking it from millimeters to meters, we're going from here to here. Okay? And in that case, the unit is getting what? If we're going from millimeters to meters, the unit is getting bigger, right?
Yeah.
Okay. So let's talk about this. What is this?
Meter stick.
Meter stick, right?
Meter stick.
Yeah. So yards would be 36 inches, which would cut off about here. Okay? This is meters. This is a meter stick. So a millimeter is every one of the little teeny black lines all the way across the meter stick, right? So how many millimeters are in a meter? How many millimeters are in a meter? Or let's do a simpler one. How many centimeters are in a meter? What does this count up to? 100, right? There's 100 centimeters in a meter, which means there are 1,000 millimeters in a meter. Okay? So what that means that we're going to do is we're going to take 500 of these to see how many meters we have. So we are going 1, 2, 3 to the left. I started here at millimeters. I'm going to the base unit. So I'm going to move my decimal point 1, 2, 3 to the left in that direction. Whichever way you're moving across here is the direction you're going to move your decimal point. So where is the decimal point in 500?
Right.
The end, right? So I'm going to take this and I'm going to move it 3 spots to the left. 1, 2, 3. So 500 millimeters is equal to 0.5 of a meter. Now let's think about that for a second. Okay, I don't want you to just memorize that you're moving this way or this way with the decimal point, but I want you to know why. This is a meter stick, right? We just said it has 1,000 millimeters in a meter. So millimeters are very small, meters are big, right? So it makes sense that it would take 1,000 of them to make up something bigger. Is everybody with me on that? Okay, so if we said that 1,000 millimeters make a meter, then wouldn't it make sense that 500 millimeters is half a meter? Right? Okay, so what you need to really pay attention to is what's happening to the unit. Is the unit itself getting bigger or smaller? In this case, we're going from millimeters to meters. So the unit is getting bigger. This is a millimeter. This is a meter. So we're going from a smaller unit to a bigger unit. Well, if that's the case, then this number is going to be smaller. It takes 500 little teeny ones to make half of the bigger one, right? Because it would take a lot more of something small to make part of something big. So if the unit is getting bigger, this number is going to get smaller. Does everybody make sense? That makes sense to everybody?
Mhm.
Let's do another one to kind of solidify that a little bit more. But let's go the other direction. Let's do... And let's go to... Okay, so notice along here I gave you what the symbols are for each of these, okay? So the symbols go, the prefixes go in front of whatever your base unit is. So if I had mm, it was millimeters, right? So on this example I have DAG. So it's the only prefix that has 2 letters instead of 1, okay? It's this one right here, and it's deca. So we have deca what?
Grams.
Grams. So decagrams. So we have 0.75 decagrams, and we are going to. No, go back. Okay. And we are going to go to DG, which is decigrams. Okay. So what you're going to do is you're going to count how many steps it takes to get from one to the other. So we're starting here, and we're going in this direction. Now, I know it's hard for you to imagine what a decagram is versus a decigram, okay? And I don't have a good example to help explain it to you, but when we're talking about just looking on the chart, is a decagram bigger or smaller than a decigram?
Bigger.
It's bigger because it's on this side of the chart, right? So a decagram is bigger than a decigram. So we are going from a larger unit to a smaller unit. So it is going to take more of these to make up this. So what's going to happen to this number? Is it going to get bigger or smaller? It's going to get bigger, right? Because you've got this is bigger. So go back to meters and millimeters. You're going from something big, and you want to know how many little ones it takes to make up something big, right? So we're going to go from, this number is going to get bigger. So let's count how much bigger it's going to get. So if we start at deca, it takes 2 steps to get to deci, right? So we're going to take that decimal point and we're going to move it to the right, because we went in this direction. We went from here to here. We're going to move it to the right 2 times. So 1, 2. So 0.75 decagrams is 75 decigrams. Okay? Questions so far? Okay, we're going to do a couple more examples. Okay, so write these down. 2,000 millimeters is equal to blank number of meters. And 15 decagrams is equal to a certain number of grams. Now, do you remember that sentence I told you earlier? How did King Henry die? By drinking chocolate milk. So that is the prefixes, guys, for the metric system. So king is for kilo, Henry for hecto, died is deca, by, B is base unit, okay? Drinking for deci, chocolate for centa, milk for Mellow, okay? So if you remember that sentence, then you remember the prefixes in order. So when we talk about, now we're gonna do these conversions, we've got 2,000 millimeters. And we wanna change it to meters. Now, where is meters on this chart?
It's
Vivian?
the base.
It's the base unit. Do not get confused when you see the M, don't go to here. These are the prefixes. So you're looking for the letter in front. If there is no letter in front, if it is just by itself, that's a base unit. So we're going from millimeter to base unit. So how many times are we gonna have to move the decimal point? If we're going from millimeter to base unit, we're going from here to here. How many times?
3.
3, right? And in which direction are we going to move the decimal point? To the left or to the right? To the left, right? Because it's going to go in the same direction as if you count it. That's why I tell you, write this horizontally versus vertically. If you write it horizontally, then the direction that you move to count is the direction that you move the decimal. So we're going to go 1, 2, 3 to the left. Decimal point is here. 1, 2, 3. So 2,000 millimeters is 2 meters. The 0.0 here is not necessary, but it's also not incorrect. So if you just write 2 here, I'm fine with that. But you can also keep the 0.0 to show where you move the decimal if that helps you out. Okay? Questions on this one? Okay, let's try the next one. 15 decagrams. And we're going to grams. Now, where do I find grams? Up here.
Base.
Base unit, right? Deca is the DA. So we're going to go from here to here. So how many times do I move the decimal point?
1.
Just once. And to the right or to the left? To the right. So I start here, and I'm going to move it 1 to the right. Now, what do I have to add right here?
0.
A 0. So 15 decagrams is 150 grams. Any questions? Okay, I want you to try the next 2 on your own. Go ahead and write them in as part of your notes. I'm going to go over the answers. But I want you to go ahead and try these 2 on your own. Now this is an L. I didn't pick a very good font for lowercase l, but so 452 liters is equal to a certain number of hectoliters. And then number 4 is 0.33 decimeters is equal to like number of millimeters. Now, go ahead and talk it out with the person or people sitting around you. That means talk to one another. I suggest if you haven't already that you write down at least the prefix symbols across. I suggest that you write those down on your paper somewhere horizontal so you can use them to count back and forth. Oh, 90 seconds. Okay, so somebody walk us through this. If we have 452 liters, how many hectoliters is that going to be? Tom?
45,200.
Okay, so explain to me how you got that answer.
Because liters is a base unit,
Okay, great.
so I looked to the left, 2,
Great.
so I added 2 zeros. And I put the decimal point.
Okay, so if the decimal point is here,
Yeah, I moved it twice. Oh wait, I should be the other one.
so which direction should it be?
It should be 4.52.
Okay, 4.52, great. Nope, that was perfect. Because it's a great way to show how if you just talk it out a little bit, you'll figure it out. So if you start at the base unit of liters, and we're moving to hectoliters, you're gonna move 2 spots to the left. The decimal starts after the 2, because this is a whole number. 1, 2, great. Good job, Dom, thank you. Okay, 0.33 decimeters to millimeters. Someone wanna talk us through this one?
I think I did this one right.
You wanna try this one?
Yeah, I think
Okay,
I think
all
I
right.
did this one right. So, wait, yeah. So that was,
Where do I start?
decimeters.
Starting here,
Starting
okay?
there, yeah. And then you move, to the right too. So,
1,
and
2.
so you move the decimal point to the right too, so it's 33.
Perfect. So 0.33 decimeters is 33 millimeters.
Yeah.
Okay? Decimeters are bigger than millimeters, right? So it would take more millimeters to make up that same distance in decimeters. That's why the number is bigger. Okay? All right, any questions? Okay, Tice, you can turn that off.